Clausius-Mosotti equation. So the relation between the dielectric constant and the polarizability of dielectric is known as Clausius-Mosotti equation. Okay, so here polarizability. So polarizability is the microscopic property. So microscopic property here polarizability. So and dielectric constant is macroscopic property. So we can easily calculate the dielectric constant for any material, but so polarizability. So for calculating the polarizability is very difficult because that is microscopic property. That means it is depends on the each atom. That polarizability is depends on the each atom. Okay, that's why. So what happened? We will call it as this polarizability is a microscopic property of the material. Microscopic property of the material. So that's why for explaining the polarizability, it is directly calculating is very little difficult. Not very little difficult. That's why Clausius-Mosotti proposed so one relation. So that relation gives the relation between the dielectric constant and polarizability. That equation we will call it as Clausius-Mosotti equation. Okay, this is what is the importance of Clausius-Mosotti equation means it gives the relation between the dielectric constant and polarizability. Okay, now to derive the relation, let us consider a polarized dielectric in which EI is the local field. Okay, then the induced dipole momentum is proportional to EI. Okay, here so induced dipole momentum is proportional to the local field. So whatever the local field act on a that dielectric material. So what is that mu? Mu is the so dipole momentum. So average dipole momentum or induced dipole momentum here. Average dipole momentum or induced dipole momentum. That induced dipole momentum is proportional to the local field EI. Okay, here proportionality constant is so alpha. That alpha we will call it as polarizability. Okay, mu is proportional to EI. Mu equal to alpha into EI. Alpha is the polarizability of the dielectric. Okay, now let us capital N. Capital N is the number of atoms per unit volume. Unit volume of the dielectric. Then polarization. So there is a relation between the polarization and so average dipole momentum. So polarization and average dipole momentum. So that relation equal to so P is equal to N mu. 1 minute here. See here that relation. So that relation is equal to P equal to N into mu. N is the so number of atoms are molecules. Number of atoms are molecules per unit volume. Unit volume. Okay. So now mu is the average dipole momentum or induced dipole momentum. Okay, so why we will call it as induced dipole momentum means because of the applied electric field. So there is a local field is induced inside the dielectric. So due to that induced electric field, so dipole momentum occur in each atom or molecule. So that's why this dipole momentum we will call it as average dipole momentum or induced dipole momentum. So now, so there is relation between the polarization relation between the polarization and so induced dipole momentum that equal to P is equal to N into mu. Okay, so N equal to we know that average number of atoms per unit volume. Okay, now coming to the P is equal to N into we know that EI is the induced dipole momentum. Already we calculated what is the induced dipole momentum act on a point A. That induced dipole momentum induced electric field. So EI. So induced electric field EI is equal. There is a relation is there that equal to E plus P by 3 epsilon naught. We will substitute the induced electric field or local field here. Okay. Now P is equal to N alpha into E plus P by 3 epsilon naught. Just multiply this N alpha into inside. Now we will get N alpha E plus N alpha by 3 epsilon naught into P. Okay. Now all so P terms one side. So this is the P term and this is the P term. So bring all P terms one side. Now so let us take a common P. So now 1 minus n alpha by 3 epsilon naught, that equal to n alpha e. Therefore, P is equal to n alpha e by 3 epsilon naught. So now this is equation number 1. So this is the polarization. This is the polarization value, P value. And so now coming to the, so there is another that relation is, so P is equal to epsilon naught into E into epsilon r minus 1. Okay, this is another relation. So let us take, this is equation number 2. How to calculate this relation? So otherwise you can directly by heart this relation. Otherwise there is a method to calculate this relation. So I will explain that method also. So by you already we know that displacement D is equal to, so formula epsilon naught E plus P. Epsilon naught E plus P. Okay, now P. So what is the P here? So P is the polarization. That polarization P is proportional to E, applied electric field here. So that polarization P is proportional to applied electric field. So now there is a relation. So P here constant. So that's is constant, that gives the relation. Now susceptibility P by E. Okay. Now substitute this P value in above equation, this equation. Okay. Now D is equal to epsilon naught E plus P. Okay. So instead of P we are substituting chi into E. Okay. Now coming to the, here already we know that there is a relation between displacement and applied electric field. Displacement D is equal to epsilon into applied electric field. Epsilon is the permittivity E. So this is the relation between the displacement and so electric field. Displacement and electric field. Substitute this value in this equation. So instead of D, we are substituting epsilon E. Now, so in both sides E is common. Both sides E is common. That's why we can cancel the E both side. We can cancel the E both side. Now relation equal to epsilon is equal to epsilon naught plus chi. Epsilon is equal to epsilon naught plus chi. Therefore, chi is equal to, so epsilon minus epsilon naught. Chi equal to epsilon minus. Here, so let us take common epsilon naught from this above equation. So in this equation, let us take a epsilon naught common. If you take epsilon naught common, here already we know that chi equal to P by E. Chi is equal to P by E. So now P is equal to, so here epsilon naught. Epsilon by epsilon naught is the, so epsilon R, relative permeability. Relative permeability, that equal to epsilon is equal to epsilon into epsilon R minus 1. Now we know that chi is equal to P by E. Substitute the P by E value. Here, therefore P is equal to E into epsilon naught into epsilon R minus 1. This is the, so relation between the polarization and so electric field. Electric field here. So substitute that value here. So instead of so this is the equation 2. Equate both equation 2 and 1 2. So if you equate equation 1 and 2 means we can get here, so epsilon naught E into epsilon R minus 1 is equal to n alpha E by 1 minus n alpha by 3 epsilon naught. Okay, here. So now bring this epsilon naught into E this side. Otherwise, so this total term. So total term, bring this side. So bring this side, and this term. So take this side. Okay. Now, so here, so E gets cancelled. E gets cancelled. So finally, this equation will become 1 minus n alpha by 3 epsilon naught is equal to n alpha by epsilon into epsilon r minus 1. Now, so bring this n alpha by 3 epsilon naught this side. Now, so therefore equation will become, so 1 equal to this total term. Here what is the common term? So n alpha by epsilon naught is common term in this side. So in this side, that's right. And so 3 epsilon naught, let's take common. Otherwise, we can take n alpha by epsilon naught. You rest. So we take n alpha by epsilon naught will happen. So n alpha by the epsilon naught we are taking common. That's why only 1 3 will come in numerator. Okay. So therefore 3 by epsilon r minus 1. If you solve above equation, so epsilon minus 1 is the so we can take LCM here. So epsilon r minus 1 plus 3 we can get here. So for final equation, so 3 epsilon r by n alpha equal to epsilon r plus 2 by epsilon r minus 1. Okay. Now this is the n alpha by 3 epsilon naught is equal to, so that means we can reciprocal both sides. So reciprocal it both sides. So therefore n alpha by 3 epsilon naught equal to epsilon r minus 1 by epsilon r plus 2. Okay, this relation we will call it as Clausius-Mosotti equation. So this relation, so n alpha by 3 epsilon naught is equal to epsilon r minus 1 by epsilon r plus 2. This relation we will call it as Clausius-Mosotti equation. Okay, so understood this Clausius-Mosotti equation. Again, once again, I will explain you. See here. So just simply, so what is the Clausius-Mosotti equation? First you have to write. So this Clausius-Mosotti equation is just relation between the dielectric constant and polarizability. So this equation we will call it as Clausius-Mosotti equation. If you have interest means you can write. So this dielectric constant is macroscopic property of the material. Polarizability is the microscopic property of the material. Clausius-Mosotti equation gives the relation between the macroscopic and microscopic property of the dielectric material. So you can write like that. Okay. Now coming to to solve this equation. Okay. To derive this equation. So what we are doing, we will apply the electric field. Due to that electric field, what happened inside the dielectric material, some electric field EI is induced. So due to that electric field, so there is a dipole momentum. So induced dipole momentum or average dipole momentum of the molecule. So our atom, so mu proportional to EI. So mu is equal to alpha into EI. Here alpha is the polarizability of the dielectric material. Now here there is some relation between the, so mu and p. So p is the polarization. So here mu is the dipole momentum or average dipole momentum or induced dipole momentum. Okay, so there is some relation between p and mu. Okay, therefore that relation is equal to so p is equal to n into mu. What is the n here? N is the number of atoms per unit volume. Okay, now just substitute the EI value. We know that EI, just substitute the EI value. If you simplify this equation, we can get the some relation. P is equal to n alpha E by 1 minus n alpha by 3 epsilon naught. Let us take this is equation number 1. And there is another relation is there. So that relation P is equal to epsilon naught E into epsilon R minus 1. How to calculate that means by using displacement formula. In the displacement equal to epsilon naught E plus P. So already we know that P is equal to chi into E. Okay, substitute that P value above equation. So therefore, so epsilon E, so here displacement equal to epsilon E is equal to epsilon naught E plus chi into E. So from this, so you can cancel the E both sides. So therefore, epsilon is equal to epsilon naught plus chi. So from this equation, chi is equal to epsilon minus epsilon naught. Okay, now let us take epsilon naught is common. So if you take epsilon naught is common, epsilon by epsilon naught equal to 1. Now therefore, so chi equal to P by E. Substitute the chi value here. So therefore P is equal to so epsilon naught into E into epsilon r minus 1. Okay. So this is equation number 2 we are taking here. So just equate the equation 1 and 2. Therefore we can get this relation here. So from this relation we can cancel the E values both sides. Now we will get the one relation. So that relation we can convert into n alpha by 3 epsilon naught is equal to epsilon r minus 1 by epsilon r plus 2. So this is the relation. This relation is known as Clausius-Mosotti equation. This relation is known as Clausius-Mosotti equation. Okay. Here, what is the dielectric constant? Epsilon r, relative permittivity is there. Na? That also we will also call it as dielectric constant. So we said that so this is the relation between dielectric constant and polarizability alpha. Polarizability alpha. Okay. So what is the dielectric constant here? So epsilon r. Epsilon r we also call it as dielectric constant. Relative permeability we also call it as dielectric constant. This is the relation between polarizability and dielectric constant. This is about the what is that? Clausius-Mosotti equation. Now I will explain the some terminology. Already I explained in last class. Again I will explain here. So permittivity. What is that? So because these definitions are very important one. So you have to know all definitions here. What is the permittivity? What is the polarizability? What is the polarization? What is the dielectric constant? These are relation you should know. So that's why I am explaining once again here. So permittivity. Permittivity represents the easily polarizable nature of the dielectric or medium. Okay, if you will take any material, so what is the polarizability? So what is the nature of polarizability? Okay, it explains the permittivity of that material. If permittivity is very high means so those materials are easily polarizable. If permittivity is very high, permittivity of material is very high means those materials are easily polarizable. Okay, now permittivity of dielectric is denoted by uh, yeah, so epsilon. Permittivity is denoted by here epsilon. Okay, if you will take medium, that is the epsilon, that is a permittivity of the medium. Suppose if you want the permittivity of the free space, so that equal to free space or vacuum or air. Okay, permittivity of the free space is equal to epsilon naught. What is the units per permittivity? Permittivity is equal to farad per meter. Already there is yesterday I told that another meter coulomb square for Newton meter. Newton meter square. Okay, that is another unit. Otherwise, one more unit is farad per. Yes, am I getting? Okay, so now here permittivity. So permittivity is nothing but so there is a permittivity of free space and permittivity of medium. Permittivity of medium means you can explain by using epsilon. You can represent by using epsilon. Permittivity of free space epsilon naught. What is the units means? Farad per meter. Farad per meter or coulomb square for Newton meter square. That is, if in case of free space, its value equal to 8.854 into 10 to the power of minus 12 farad per meter. Now, dielectric polarization. Dielectric polarization. In the presence of electric field, induced or separation of positive and negative charges takes place in the dielectric. Each separated charge acts as a dipole and has dipole momentum. So that means dipoles are induced into the dielectric and exhibits net dipole momentum in the electric field. This phenomena is known as dielectric polarization. Okay, so polarization is nothing but so if you apply the electric field, so otherwise if you place the dielectric material inside the uh, electric field, what happened? That material will become polarized. That means those charge particles are separated. Okay, so due to the separation, what happened? So polarization is occur. This phenomena is known as So this phenomena, separation of charge particle. So this phenomena is known as dielectric polarization. Okay. So dielectric polarization. So now there is a relation between the mu and p. So p is equal to mu by v. So mu is the induced dipole momentum or okay. So induced dipole momentum per unit volume. So one more definition is induced dipole momentum per unit volume is called as polarization or dielectric polarization. Okay. Now, so here. Okay. So there is one more relation also there. So that equal P is equal to N into mu. Here, so N is the number of atoms per unit volume. So here small n is the so total number of atoms. So total, yeah. So if N is the number of molecules per unit volume, here N is the so total number of molecules. So yeah. So now we can take the relation like this. Okay. Dielectric polarizability. Dielectric polarizability. The polarizability of dielectric to get separated in the presence of electric field is known as polarizability. What is the definition means? So the ability of dielectric material. So so remember this one. So the ability of dielectric material to allow to get separate its charges to get separate. Okay, so if you place the dielectric material inside the electric field, what happens? Charges will be separated. So positive charge, negative charges are separated. So the ability of dielectric material to allow its charge to get separate. That ability is called as so polarizability. So simply dielectric polarizability. Dielectric polarizability of the material. Okay, so this is the definition of polarizability. So how to calculate that polarizability means? So the dipole momentum. There is a dipole relation between the applied electric field and dipole momentum, net dipole momentum. Mu is proportional to E. So mu is equal to alpha into E. So therefore alpha equal to mu by E. Okay. So there is a one more definition we can give here. So that polarizability alpha is equal to so mu by E. So that means dipole momentum per unit electric field. Dipole momentum for unit electric field is called as polarizability. So this is another definition of the polarizability. Okay, so polarizability means the ability of dielectric to allow its charges to get separated. Okay, that is the one definition. Another definition is so dipole momentum for unit electric field. Dipole momentum per unit electric field is called as so dielectric polarizability. Okay, now susceptibility. So what is the definition of susceptibility? So when dielectric is placed in electric field, it is polarized. Already we know that. So that polarization is P bar and applied electric field is E bar. There is a relation between the polarization and electric field. Okay, so this P bar means it gives the direction of the polarization as well as so direction of the applied electric field. Okay, so now P bar is equal to chi into E bar. So there is a some constant in between the so P and E. So that is equal to chi. That chi we will call it as susceptibility. Susceptibility. So chi is equal to P by E. Definition from this. The dielectric susceptibility may be defined as the ratio of polarization vector to the electric intensity in the dielectric. Okay, so this is the ratio of polarization as well as electric intensity. Electric intensity is called otherwise simply electric field, applied electric field. Okay, so that is called as susceptibility. Now coming to the electric displacement at D. Electric displacement. The electric displacement at a point is defined as the product of electric field strength E at that point and the permittivity of the medium. So just dielectric displacement is the so here there is a relation between the electric field strength and so displacement, electric displacement. That relation B bar is equal to epsilon into E bar. Simply, what is the definition? Means multiplication of electric field strength and permittivity of the medium is called as electric displacement. Okay. Now here already we know that K is equal to epsilon by epsilon naught. K is equal to so here epsilon by epsilon naught. So K, what is the K here? Dielectric constant. So dielectric constant, otherwise we can also call it as epsilon R, relative permittivity. So relative permittivity. So relative permittivity. So that equal to epsilon R. Epsilon R also called as dielectric constant. That equal to epsilon by epsilon naught. So that's why instead of epsilon permittivity, we are substituting K into epsilon naught. Otherwise, there is one more relation will be there. So that relation